Hey everybody. In class today we talked about writing ratios and proportions, and we did a little bit of solving proportions. Tonight we're going to look at another strategy we can use to solve proportions, and this is going to be a little more useful when the types of proportions we're dealing with get a little trickier. And that is called finding the cross product or cross multiplication. Whenever we have two fractions that are equal to each other, like in the example here we have 3/4 and we have 6/8, right? We know that these two are equal to each other. If we take the cross products, which is when we multiply the denominator of one fraction with the numerator of the other fraction, same thing here, numerator times denominator, the cross products are always equal, right? 3 times 8 gives us 24, and 4 times 6 gives us 24. And that works for every fraction. If we have a over b equals c over d, remember b can't be 0 and d can't be 0, a times d is always going to equal b times c. A times d is going to equal b times c. The cross products are always equal. And we can take a look at another example. Let's say we have 6/9 equals 10/15, right? These two fractions are equal. We know they're both equal to 2/3. And if we take the cross products, 6 times 15 and 9 times 10, 6 times 15 is 90, and 9 times 10 is 90. So this is always true. Cross products are always going to be equal, even if we have a variable. So we can use this to solve proportions. In this case, I have 8 times 15. 8 times 15 is equal to x times 6, or 6x. 8 times 15, 8 times 10 is 80, and 8 times 5 is 40. 80 plus 40 is 120, equals 6x. And we divide by 6, and we get x equals 20. So 8 over 20 equals 6 over 15. Now, we can also use this to solve proportions when our proportions are a lot more complicated. In this case, we have a really complicated proportion, but we're going to do the same thing. I have 4 times x minus 3 equals 8 times x, right? We're just going to find the cross products, set them equal to each other. And now we can solve this just like we'd solve any equation. I'm going to draw my line. I'm going to use my distributive property. I got 4x minus 12 equals 8x. Now I need to get rid of one of my variables. I'm going to eliminate this 4x minus 4x. And I have negative 12 equals 4x. I divide by 4. And I get x equals negative 3. So our answer to this multiple choice question is B. Let's see what this looks like in real life. Each day, the seals at an aquarium are each fed 8 pounds of food for every 100 pounds of their body weight. A seal at the aquarium weighs 280 pounds. How much food should the seal be fed per day? So, we want to know how much food should the seal be fed per day. We can use F to represent that. F equals food per day. Now, I know that they get 8 pounds of food for every 100 pounds of body weight. So that could be a fraction, and I know this relationship is going to be proportional. So 8 pounds of food for every 100 pounds of body weight. And I know that the seal weighs 280 pounds, so I'm going to want to put a box around that too. 280 pounds because I want the body weight across from each other, and the amount of food is going to be across from each other. So now I can find the cross products or cross multiply to find our answer. 100F is equal to 8 times 280. Now I need to figure out what that is. 8 times 280 8 times 0 is 0. 8 times 8 is 64. Carry the 6. 2 times 8 is 16. Plus 6 is 22. So I have 100F equals 2,240. And now to solve for F, I divide by 100. And I get F equals, when I divide by 100, I just move the decimal over 2 places, 22.40 pounds. All right, here's our last example. On the map shown at the right, Cleveland and Cincinnati are 4.2 centimeters away from each other. We want to use the scale on the map to find the actual distance between the two cities. So let's underline that. We want the distance between the two cities. Let's use D to represent that. D equals the distance in real life. And our scale tells us that 1 centimeter on the map equals 85 kilometers in real life. And we also know that they are 4.2 centimeters away from each other on the map. Now we can set up a proportion. One fraction, I already know, is 1 over 85 because that's the scale. 1 centimeter for every 85 kilometers. And when I set up my proportion here, I'm going to need 4.2 on top in the numerator because that's where the centimeters are. And 85 kilometers is on the bottom, so I need D on the bottom because that's our distance in kilometers. Now we can use the cross products or cross multiplication to solve. 1 times D is D, and we have 85 times 4.2. So 85 times 4.2, 2 times 5 is 10, 16 plus 1 is 17, fill in the 0 there, 4 times 5 is 20, 8 times 4 is 32, plus 2 is 34. Then we just add, we get 0, 7, 5, and 3. And because we have 1 decimal place in our problem, we need 1 decimal place in the answer. So our distance is 357 kilometers.